Problem 3 asks us to consider 4x squared plus 8y squared minus 32x minus 16y plus 16 equals 0. So we notice that there's an x squared term and a y squared term, so this is not a parabola. Both of those terms are positive, so this is not a hyperbola, but there's a different amplitude on the x squared term and the y squared term, so that makes this an ellipse. The next thing that we want to do is we want to do a little bit of rearranging of this equation to get it into the standard form of an ellipse. So I'm going to collect my x terms and my y terms and move my constant term over. And then I want to pull out a greatest common factor as a constant term. I'm going to leave my variables attached from each of my x's and y's. And then dividing everything by this 4 is going to make it easier to make the standard form with my y terms, because I do need to complete the square here. X squared minus 8x is not a perfect square trinomial, and we need it to be a perfect square trinomial, so our exponent is outside of the parentheses. We do know that if we add half of our b term, which is -4, squared, which is 16, to both sides, that we will have a perfect square trinomial on the left and a balanced equation. So that perfect square trinomial factors down to x squared, or x minus 4 squared. And the right side of our equation simplifies to 12. The next thing that we want to do is we want to do the same process with our y's. But to make that a little bit easier, we can divide everything by 2. And then we can look again at that b term, -2. If we divide that by 2, we get -1, and if we square that, we get +1, so we're adding 1 to each side. We can then factor the y terms to y minus 1 squared, and we get 7 on our right side. This is still not in the perfect form for an ellipse. We need to have that equal 1, so we're going to multiply everything by 1/7 to balance that equation and get it equal to 1. That leaves us with x minus 4 squared over 14 plus y minus 1 squared over 7, that 2 didn't belong there, equals 1. All right, that's the equation for our ellipse. So we're next being asked to find the center. Remember, our center comes from h and k. So that tells us that our center for this ellipse is at 4, 1. The next question is for us to find the vertices. We know that vertices are going to be at h plus or minus a comma k. And we know that a is the square root of 14 because a squared is 14. So that would put us at 4, because h is 4, plus or minus the square root of 14 with an x coordinate of 1. Those are our vertices. Points on the minor axis are co-vertices. Would be at h comma k plus or minus b, and we know that b is the square root of 7 because b squared is 7. So that would give us 4 comma 1, because that's our k value, plus or minus the square root of 7. Last thing we need to do is graph this equation. So 1, 2, 3, 4. 1 is our center. Square root of 14 is slightly bigger than 3. And 1 plus or minus the square root of 7. Square root of 7 is slightly bigger than 2. 1 plus slightly bigger than 2 is a little bigger than 3. And then we just connect our dots.